I'm Ann Giblin. I'm a senior scientist at the Marine Biological Laboratory. I work on salt marshes and estuaries, and my specific interest is in how elements like nitrogen and carbon cycle through these unique environments. There's some very interesting and unique characteristics of the Plum Island Great Marsh as opposed to some of the salt marshes below us in Cape Cod and even further south. The first one is the very high tidal range. You've all seen out there we have a 9 to 10 foot tide range. This makes it a problem if you have a dock perhaps, but it creates an interesting situation with the marsh. It means that there's a very large range over which the marsh can survive, and it also means that the marsh is somewhat more resilient to sea level rise because of this large tidal range. A lot of the animals that we think of being very important in some of the more southern marshes, even those on Cape Cod, simply can't exist here because of the low winter temperatures. Well, blue crabs are exceedingly rare here, whereas they're very important to the south. Things like fiddler crabs are much more common to the south and do not occur in the Plum Island marshes. One of the important functions of salt marshes is they really perform as nurseries for a lot of important fish, such as striped bass, bluefish, or juveniles, small fish or adolescents. They're specifically coming up here because this is a very rich place for them to feed and to grow, and there's protection from some of the larger predators. The other function that marshes serve is to actually help remove some of the material that comes from land and essentially clean it up before it reaches the ocean. We think of nitrogen as being one of these, that the marshes take up the nitrogen and remove it before it enters coastal estuaries that might be less able to assimilate it and where it might lead to algal blooms or other problems. Another function that marshes serve is to take carbon dioxide out of the atmosphere and store it as peat. Maybe you've had the experience of finding a buried staddle or something deep in the peat. This is because the marsh is taking carbon dioxide up from the atmosphere, turning it into plants, and then as those plants die and decompose, that material somewhat stays in place and eventually accretes, so the marsh surface gets higher and higher. That accretion of carbon represents a storage of carbon from the atmosphere. Scientists call this blue carbon because it's a way of mitigating CO2 in the atmosphere by storing it in marshes, and we're increasingly finding out that areas such as marshes and seagrass beds may be very important in terms of their area for how much carbon they're able to store. Well, there's a number of things that are changing right now that may or may not be very important to how the Great Marsh functions and ultimately whether or not it survives. The most important, of course, is sea level rise. Right now, sea level is rising at a very small rate, although it is getting faster. It's about 2.5 millimeters per year. And this rate of sea level rise is still slow enough that for the most part we feel that the marsh is keeping up with sea level rise by burying that carbon and by burying sediments. But the marsh is stressed from several directions. The sea level rise rate is going up, and at the same time one of the other ways the marsh keeps up with sea level rise is by accreting inorganic sediments, sand, clays, other materials to help it keep up with sea level rise. Those materials used to come from the watershed a long time ago. Of course, now all the rivers are dammed, so we don't see any more sediments really coming in any appreciable quantity from the watershed. So this loss of sediments to the marsh over the long term means that the only way the marsh can continue to keep up with sea level rise is by building more marsh organically, which is a limited process. It can only be a few millimeters a year, or by essentially rearranging itself, constantly making itself smaller and using the material that's eroded away at the channels to deposit onto the marsh surface. People also worry for marshes and estuaries what the role of nitrogen is, increased nitrogen coming from the watershed. Plum Island is fortunate in that regard. Right now, the nitrogen inputs to the marsh and to the estuary are relatively low compared to many places in the Northeast. And there's a lot of reasons for this. One of the most interesting is that luckily for Plum Island, a lot of the development is far back in the watershed, and as that nitrate moves through the system, we see it being removed by a variety of processes so that the load of nitrogen right now to Plum Island is still fairly low. That, of course, could change with increased development or a loss of some of these functions within the watershed and lead to issues of eutrophication as well. When we talk about climate change, there's a number of different aspects which we have to think about how it's going to affect the marsh as a whole. The first, of course, everyone thinks about temperature, and we think temperature might have an impact on what is happening in the Great Marsh. Specifically, temperature might lead to a change in the plants and animals, especially the animals that we see in the marsh now. As I mentioned before, some of the organisms that are found further south are not found here. We might well see those organisms coming into the marsh as temperatures get warmer. On top of sea level rise, we have storms, and when storms hit at a high sea level, then we have damage both to the barrier beach and damage to human infrastructure. The future of Plum Island, of course, has changed over geologic time and is likely to change again. So to some extent, whether or not the marsh itself survives is going to be dependent upon whether or not the marsh can rearrange with these forces. But of course, we have a lot of infrastructure in the way. We have houses, we have dikes, we have dams, which prevent the marsh from moving backward as sea level rises. So that's going to be a big challenge to see how we plan for the marsh moving backwards if we can, and plan for the eventual rearrangement that will no doubtedly occur. The other function that marshes serve is to actually help remove some of the material that comes from land and essentially clean it up before it reaches the ocean. We think of nitrogen as being one of these, that the marshes take up the nitrogen and remove it before it enters coastal estuaries that might be less able to assimilate it and where it might lead to algal blooms or other problems. We think about the nitrogen cycle in terms of fertilizer. Nitrogen helps plants grow better. In excess, we know that it leads to algal blooms, but we tend to concentrate on the role that nitrogen plays with plants. My own research really focuses more on the role that bacteria play in the nitrogen cycle. Bacteria are capable of taking the nitrogen that is available to plants and converting it back to nitrogen into the atmosphere, which is largely unavailable to plants. So the way that bacteria in sediments and in the water column process this nitrogen, the way that they remove it from the ecosystem, the way that they use it to break down carbon, or the way that they might use it to convert to other gaseous forms, such as N2O, which is a greenhouse gas, are fairly important to understand if we're going to really get into deep understanding of how inputs of excess nitrogen are going to affect the ecosystem both now and in the long term. I'm Ann Giblin. I'm a senior scientist at the Marine Biological Laboratory. I work on the Plum Island Ecosystems long-term ecological research site here in the Great Marsh. If you'd like to learn more about the research we're doing, the website has materials both for the general public. It has photos, as well as the data that we're collecting, which everyone is welcome to look at or download if needed. Thank you.